Today, I want us to discuss very important concept of CREO analysis, that is multi-objective design study or MODS in CREO. And basically, it involves having a design. You can see I have a design here with these dimensions. You optimize these parameters based on the goal provided, then you get your optimized design. In this case, my goal was um, reduce, minimize mass, or that's my goal, was to minimize mass, but at the same time, increase principal inertia. Therefore, we want to maximize principal inertia, but reduce mass. And this is the final model I got. Therefore, let's analyze this to illustrate step by step on how you can do this. Therefore, I have this model. Let me just go back how it was. I just made a simple sketch. Even I didn't define it, fully dimension it. Simple sketch like that. Let me just fully define it here. Then on this sketch, I want to sweep. I used sweep command here to sweep an I-beam. Therefore, if you go to sketch, this is I-beam I'm sweeping. This is the flange length, flange thickness, this is the height of the beam, this is the web thickness, and we want to optimize these three parameters to reduce weight at the same time maximize principal inertia. First thing I did is you have to assign material. Right now I'm using, let me see, I'm using what? I'm using steel. Yeah, I'm using steel, and you can change the units here. I want to use kilograms per millimeter cubic. Use this method of conversion. I say okay. Okay. Therefore, select this material and assign. You go to the steel, double click, say okay, say okay. Therefore, assign material as per your requirement. Something else you need to do is to give your dimensions a name that is easy to understand, because right now when you sketch you'll get SD3, SD1. What I mean is if you select this D, you can see when you select 40, I just renamed to flange width. This one might be SD something, sketch dimension SD, as well as height. Just dimension the parameter you want to change. Most of time height remains constant, but you want to maximize web thickness 20, flange length and thickness. Then let's go back. Okay, next, depending, sometimes you might have a variable. In case you have a variable sweep here, variable cross section here, just in case you have that one, you can define a cross section where you are going to take your parameters. Like now, I want to define a sketch, just a plane, any plane. It's not a must for you to do this because we have a uniform cross section, especially here, but here will not be uniform. In case you want to define a plane, you can define a plane. This plane will be used to take the measurements. Therefore, if I go to here, let me just make it a small plane like that. Yeah, and you can call it section plane. Okay, I need to give it a name. Section plane. Then we can create a plane on our part using the section plane by go to view, section, use this plane, and we'll get a cross section there. You can give it some display, and you can give it this default. You can use some hatch, okay, and maybe if you want to increase the number of hatch, just go here, edit, and magnify or reduce or change angle, rotate. If you want to change color as well, give red. Whatever you want, you can just play with them. If you want to change the standard used ISO, those maybe ANSI, just play with them. Okay, after that, we need now to determine, remember I said the goal is to reduce mass, maximize principal inertia. Let's start by mass analysis. Let's go to analysis, mass properties. Here the mass properties for the geometry that I want to save as a feature. What I need, if I see preview, you can see something here. I'm getting my mass in tons, and maybe you don't want this. You can create your feature that has the you can create your parameter that has your defined mass. Okay, I'll show you mass unit. I'll show you how to do that. For me, my interest is mass. If you want to create a center of gravity, if you want to have a point on the center of gravity, you can do this here, coordinate and a point. But for me, my is mass. Maybe you might have a task to reduce volume. You can create volume as well, or whatever you have. But for now, I'm not using principal inertia. Yeah, I'll use something else here because I want to focus on the cross section when getting the inertia mass here. Then say okay, and I can just rename this for ease of your understanding. I do a rename here underscore tone like that. Yeah, then we can create a relation to get mass in kilograms. Just go to analysis here. You do what we call a relation, which is called mass conversion. Yeah, you can do this by changing the units, but I want to show you in case you don't want to change the units, how you can go about it. Yeah, local parameters, I can say mass, I can call it mass underscore kg, like that. Then if you scroll this side here, what are you getting? Mass. Instead of ton, can use kilograms. 1 to become 25 here. Then you can say insert into relation and say this one equals, look for feature that is a ton, to look for the value here and convert it for you. Okay, and insert selected. Okay, okay. Therefore, if you rename this one here, you can say mass prop ada kg. Let's just delete this here. So I also this like that, so that yeah, you can just rename this one here. Basically, you can leave it like that. Let's see the parameters here. We can see the mass is now 3.72 kilograms. You can see the units here is kg. Yeah, you can also change, you can create parameters and assign the units you want. Next is I want to use what we call X cross-section mass properties of our plane here. And you can see from our plane, we can get inertia tensor here. These are the parameters that you can get from the solid structural mechanics. And I want to not saved feature. And here, my main interest is principal inertia. And I want the principal inertia largest, because you know that the bigger the principal inertia, the beam tends to resist bending moments. If you learn, you can do some research on the importance of the principal inertia. Yeah, principal inertia is good for this type of beam to resist bending moments. Therefore, my interest is largest, because I want to have the largest. I want to observe this, but at the same time, I want to reduce mass. And you know that as you reduce mass, the principal inertia will have to reduce. You see that when you perform the actual analysis. And let me give it a name. I can say principal inertia max. Go center and say okay. If you go here now, you'll see that I have a principal inertia max. This is a value here with that is the units. That is it is at the power 4. This what I'm using here. You can get it from this icon here. You can just go to the information. I'm using a feature information in case you are like, where is this icon? Okay. Then from there, I have the mass in kilograms, and I have principle of inertia, that is maximum. I want to maximize this and reduce mass. Therefore, I go to MODS and I give it a new study here, call it I-beam optimization. In I-beam optimization, well, the first thing you do is you set up a master table that has variables. Let me just pull this aside. This master table, you should define a variable and goal. And I'll say the variables, if you select here, add dimension variable, select your body, dimension should appear. And I want to change this, that is a flange width here, you can see. Change this web thickness and flange thickness. I want to change flange width maybe from 25 to maybe 50. Web thickness, as you know, web has to be less than flange, therefore it can never exceed 25. Therefore I give it maybe 24 or maybe 20 from 10. Then thickness from 2 to 10. I'm using random values depending on the design constraint. Therefore, you can use a process value and you can add more. I can add this as well. But for me, I want to focus on, I can remove it. I want to focus on the first three. Yeah. For some reason, this is not being removed. Okay, let's go to set goals first. The goals I want to set, I'm using kilograms, and I want to also, another goal is principal max inertia, those two, and I want to remove this. Okay, now I can highlight. I want to focus on these three, and these are my goals. By sampling method, the sampling means the value is going to assign from 25, it will sample, it does the sampling automatically, but you can define, you can define your value here, say vary 40 to 41, 42. You can give the variation, but most of the time just give it on automatic to save time because software will do that for you. But in case you have just two unique values, you can now use manual sampling method. You say okay and run. I'm going to run, these are the number of experiments. You want to vary these dimensions how many times? Let me use 300 times. The higher the value, the more it will take to run. But for me, let me just pause a video as it runs in the background. You can see running very fast because it is a simple model. Yeah. Yeah. The analysis was able to record 300 iterations. You can see from the first iteration, the mass was this value, principal inertia. Therefore, it will take me forever to go through this list to look for a minimum mass or whatever I'm looking at. The first thing I do is take these values and graph them. Graph. To create a graph, on x-axis, I want to have mass, but on y-axis, I want to have principal inertia. Let's graph this. These are the variables. You can also graph them if you want. You can see we get a scatter diagram here whereby points are scattered all over. You can see the mass, it was from 2 to 5, and I want to reduce mass at the same time maximize principal inertia. And I don't know what to use because line here I can't pick things randomly. What I'm going to do, let me close this and right click here and say derive. I'm going to derive Pareto first. In this Pareto, I want to minimize mass but maximize principal inertia and call it Pareto for lack of a good word to use. See, okay. Now Pareto, when I set that condition, it gave back 30 from 300 to 30. I can now graph this again. Y principal, X mass graph. Now you have just 30 points. You can see I have 30 points now. I can now decide maybe this here. Maybe I'm okay. I can say I'm okay to use to accept mass of 4. I can say the mass between, give me maximum value between 3 to 4. I'm okay to get 3 to 4 mass. Therefore, give me maximum of principal within a mass of 3 to 4. I can now narrow down again because these points, yeah, they are 30, but still I need to go to a specific point. Cross again, derive. This time I'm going to use constraint mass from 3 to 4. Give me maximum. Can say max principal. Let's see what it gets. It gets 10. Here again, let's see. Now I have 10 and automatically this becomes my answer. Yeah, therefore I just go back to the points, look for this point here, this one here, that is 3.9 something, and use it. Therefore, just close here, look for 3.9, and just scroll down. Yeah, this is 3.9. Therefore, with this 3.9, you can see I have 22. It has the maximum principal inertia than them, but the mass is still high. Okay. If I want to accept this, I can right click and say show model. Therefore, this is the model after optimization from this. You can see. Let me just paint screen here. From this, we end up with this show model. This one here. You can see it's now optimized. Yeah. And If you want, at the same time, you can save this model. Save model, give it the name you want. You can open it in a CREO and do whatever you want to do with it. That's how you can use multi-object design study. Next time, I'm going to use multi-object design study with statistical study, design study, to be more precise on how you sample this data, just to understand how is this data distributed using normal distribution graphs. We're going to go deeper to this, yeah, in combination MODS. Thank you and stay tuned for more such videos. Bye.